Data modeling overview. It's good to start with a few key concepts like customer, order, and product. These will be your classes or the circles that appear in Explorer. And then for each concept or class, define a few key attributes like maybe customer name, customer address, or product price, and define at least one relationship to or from your class to another class. Otherwise, your class is isolated and not really participating in the knowledge graph. The data model is really a kind of meeting in the middle between, on one side, what concepts you or your Explorer user would really like to see, and on the other side, what data you have available to populate your knowledge graphs. The data models should be composable like Legos, and reuse is the key. To make them reusable, try to use language that is very encompassing and will resonate with your Explorer users. Maybe your company uses terms like clients or accounts or subscribers, but try to use the widest possible terms, perhaps customer, and then later you can get more specific and make subscriber or account a subclass of customer. You're building a semantic layer here, so whatever you decide here is what the Explorer's users will see. But don't worry, all these things can be edited later in just a few clicks, so there's no pressure. From a naming perspective, data models really encode the meaning of your data and the names you use to convey to the Explorer users what your classes and relationships will contain. So your terminology should align with your domain experts and, equally importantly, your Explorer users. You might also want to decide things like whether you're going to use upper or lower case or camel case, whether you're going to use singular or plural, would be customer or customers. It doesn't really matter what you choose, but consistency is really valuable for reuse and familiarity. Let's talk about some modeling terminology. First of all, we have classes that you're already familiar with from an Explorer perspective, but to define it a bit better, a class defines a set of individuals or instances that share common characteristics or that belong to some category. They're much simpler than classes you might be familiar with from Java or Python or any object-oriented language. There are no methods or functions. Although they do support inheritance, a subclass will automatically have the attributes of its parents. If we click on the little 3 here, you'll get a name of the actual attributes in the class. They are department name, description, and parent in this example. And then relationships between classes are indicated by this arrow, and they have direction to them as well. Let's have a closer look at the designer canvas. This is the canvas, and we can see all our classes with our edges, and these dotted lines indicate mappings from resources. This icon resource here is a CSV file. We could also have JSON files, and we could have SQL tables. The SQL table will look much more like a workbook in a spreadsheet or something like that. When they're coloured blue, it means that we're happy that the classes or the edges have been populated with data that have been mapped to some data sources. Usually the mapping is direct from a resource to a class, and then we'll use one of the resources to map adjacent relationships between classes. Quick tour of the Stardog Designer model user interface. Here is where you will import data from models from Stardog databases. Here's where you specify data to be mapped. These can be either CSVs or relational tables or something from a JDBC connection. Here's where you just create classes, and here's how you create relationships. Here's how you delete any concept, a class or a relationship. Here's where you add mappings from project resources. This is where you create and manage rules. This is between model and mapping. Here you can toggle between the model and mapping views. Here's the settings to customize the project. Here's how you export the project, and very valuable. We'll look at that in a lot more detail. And finally, here's how to publish the project to a Stardog endpoint. When you click on a class, you have the opportunity to edit some of its details. First of all, here you can edit its name. Perhaps you called it customers and you want to call it customer. You can change it here. You can also customize the IRI. If you're familiar with RDF, you'll know what an IRI is. If you're not, we'll be talking about that later in any case, but you can edit the IRI here by clicking over in this area of the box. You can also manage parent and child classes. So for instance, if we had feline here, we might have as a child class, family cats, and a parent class, mammals or something like that. We're not using subclasses in our demonstration today, but they're the sorts of things you can do. This is where you add relationships. You can add additional relationships, or you can change the direction of an existing relationship here. This is coming out. It's an outgoing node from the node, and this would be incoming. And here are all the attributes inside the class. And again, you can change any of these by clicking on these. You'll be able to edit them too. We'll have a look at that in a moment. You can also delete the class from here at the bottom. Here's how we edit relationships. By clicking on the relationship, it'll open up this box here, and you can change its name. Maybe you want to change it to uppercase or completely change it. You can add it just as you could earlier. You can specify its source and target classes. Some relationships have multiple. We can reuse made purchase, so we could have customer to purchase linked by the made purchase relationship. But we also could have, for instance, employee makes a purchase or made purchase. So we can support this, reuse the same entity among different classes. And when you do that, you'll have a longer list of source and target classes here in the list. Once again, you can also modify the IRI as you can for any resource, and you can delete the relationship entirely. Editing attributes is very similar. You can change its name. Maybe you want to change it to email address. You can add a description. You can specify the data type, and this is quite important, or useful, I should say. If you specify everything as a string, the database will work absolutely fine. But if you specify it as it really is more correctly, you get some added advantages. When it's a string, then in Explorer, you get the chance to say it's equal to a string when you're doing a filter. In the query, you can say it's equal to a string or contains a string or something like that. But if it's an integer, then that filter will become less than, greater than or equal to, so much more valuable. Similarly, if it's really a date, then say it's a date here, because then you'll have before and after or between, and you'll have those nice date pop-up windows that appear in the query builder when you're building the query. Once again, you can edit the IRI, and you can manage class associations here like you could before. You can also manage sensitive property group members, so you can specify which attributes are really sensitive. Maybe you've got some sensitive information, maybe SSID or something like that. And once again, you can delete the attribute here as well. For a demo, we will use this stored demo dataset. There are links in the description for you to download and follow along. So each table here is a CSV file, though it could equally be an SQL table. The process to map and ingest the data is really very similar. The four classes we have, or in fact the four tables we have, are US customer, purchase, product and category. These tables are related to each other. For instance, this CID corresponds with the CID here, so that this purchase made on this date was made by this customer here, 206. Similarly, this is the product ID over here, which corresponds with ID here, and department ID here corresponds with this category. We also have a self-join inside this table. We see that ID1 has parent ID2, which telling us that shoes, the category shoes, has parent, the category clothing. When we create and map to a model, the most natural model is this model shown here. We map each table to its own class. So US customer to customer and purchase to purchase and so forth. And then we map each relationship from class to class using the columns that correspond in the individual classes. Let's go into Designer now and create the model. First, go to cloud.stardog.com. Go to Designer, and once there, choose New. We could import an existing project if we had one, but we don't, so we create New and enter a project name. And choose Blank Canvas. Now we want to create the classes associated with the dataset. The first one was Customer, so we'll create the class called Customer. And we'll give it a description if we wish. We're not going to use parent or child classes in this model. Actually, we don't have any subclasses. We will have relationships like make purchase, but we won't do these right away. Next thing to do is enter the attributes. And the attributes are really the columns of the data that we want to import into the class. In this case, it's email, first and last name, and SSN, and they all have the type string. And now when we hit create, the class will be created on the canvas. We can see here, if we click here, we can just see the 4 attributes if we add it. That will disappear if we click again. And we can make any edits that we wish now by double clicking on customer. And we can edit the customer class name or the people who buy or any of these. We can make any edits we wish to make. Proceeding in the same way now, we'll make the product class. So add a class. And add several attributes that have different data types. There are some integers and strings and floats as well. And then hit create, and the product class is created.